Hello, welcome to part 204 in our coverage of Alberta's Algebra and Number 4 curricular outcome. This is going to be a deep dive into polynomials. We're going to look at our curricular outcome, review some polynomial terminology, go into collecting like terms in more detail, and talk about examples and exercises. Our curricular outcome is to demonstrate an understanding of the multiplication of polynomial expressions, limited to monomials, binomials, and trinomials, concretely, pictorially, and symbolically. That limited to statement should make more sense after this lesson when we define the binomials, monomials, and trinomials. Our polynomial terminology. A polynomial has a form where we have coefficients multiplied by some variable to positive or whole number exponents. If we have n terms or n plus 1 terms, we'll go from n to 0. A subscript 0 is usually our constant. And then the rest have subscripts to label them that match the degree or the exponent on the variable. Every one of these coefficients is an integer. The degree of a polynomial is the highest exponent present in the polynomial. So each term, that degree is the exponent of x. The degree of the whole polynomial is the highest degree term it contains. The leading term of a polynomial is the term that has the variable to the highest degree. So it would be anx to the n. And the leading coefficient is the coefficient of the leading term. So up here, that would just be an. So this terminology, not necessarily this notation with the subscripts, but this terminology should be familiar from junior high. Now, like terms are terms with the same variable and the same exponents. So collecting our like terms. A single term of a polynomial is one variable with some exponent with one coefficient. Like terms are terms that have the same variable with the same exponent. By convention, polynomials are written with the terms sorted in order of decreasing exponents. So you start with the highest exponent and work your way down to the constant. When we collect like terms, we take all the terms with the same variable and exponent and combine them into a single term. Like terms are combined by adding and subtracting the coefficients. Terms with different variables or exponents cannot be combined. So x and y do not combine. X squared and x cubed do not combine. Xy squared and x squared y do not combine. It has to be a perfect match for everything but the coefficient. Let's see some examples. So here, to collect some like terms in 3x minus 5y plus 2x plus 7y. Let's take a look at our variables. We start with a 3x. So what other terms have an x in them with exponent 1? Well, that's the 2x. So 3x plus 2x is 5x. Our next term is the negative 5y. So which other terms have y to exponent 1? That's the 7y. We combine these. Negative 5 plus 7 is 2. When we're combining like terms, the variables and their exponents will not change. So there we go. This combines to 5x plus 2y. Collecting like terms here. All right, again, we go in order of decreasing exponents. Our highest exponent here is x squared. So 6x squared minus 9x squared make negative 3x squared. 6 minus 9 is negative 3. Now we look for our next exponent of x. That's x equals 1. The 3x plus 4x combine to make 7x. Now our constants. Negative 7 minus 15 is negative 22. This is now fully simplified. We're going to collect like terms in this. Notice that we have x squared, x, y squared, y, and constants in here. So collecting like terms in this. Let's start looking at our x squared exponents. When in doubt, go in alphabetical order and leave your constants to last. 4x squared minus 3x squared is just x squared. Now, 5y squared is our only y squared term that comes in. So we have no other y squareds, nothing cubed, only two variables. Let's look at our x now. If we had an xy term, it usually goes between them because, as I said, we alphabetize. So our just x terms, that is plus 2x minus 3x minus x, 2 minus 3 minus 1 is negative 2x. Our linear y terms, negative y plus 6 is a plus 5y. When you are working with something this big on paper, I recommend crossing out or putting tick marks to something so that you can track and make sure each term has been accounted for. Finally, our constants, negative 4 plus 7 is a plus 3. There we are. Here is our simplification. It has gone from 10 terms down to 5. Right, exercises. Time to try your own. Collect like terms here. Pause now and take the time you need. Right, this simplifies to 4x squared plus 2x minus 5. Now here, notice this time it's only x, but exponents go up to x cubed. Pause now, take the time you need. Collecting our like terms on this one, we have a negative x cubed and a positive, so they actually cancel. Fully simplified, this is 7x squared minus 4x plus 2. Final exercise, collect like terms here, where we have x squared, xy, y squared, xy, and constants. So we should have 6 terms in the end, because we have 6 different combinations of variables with different degrees. Fully simplified, here we go. Negative 5x squared plus 4xy minus 2y squared plus 4x plus 8y plus 10. This is written in the conventional order, alphabetizing variables, but prioritizing degree. So x squared is degree 2. xy is also degree 2 because there's 2 variables. So is y squared. Those terms go first. And alphabetically, xx is before xy is before yy. Then we do the x, the y, and the constant. In summary, a polynomial is the sum of a collection of terms. 1 term is monomial, 2 terms a binomial, 3 terms a trinomial. Polynomial terms have coefficients, variables, and specific exponents. Like terms have the same variables with the same exponents. They can be collected by adding the coefficients. When terms are collected, it's conventional to write the polynomial terms in order of decreasing degree. If 2 or more terms have the same degree, they are alphabetized by variable. That wraps up this look at our polynomials. If you have any other questions, please post them in the comments. Let me know, and I will try to respond in a timely fashion.